So those first quadratics were pretty simple. I need something a little harder. Do you have anything? I'm glad you asked. It's your girl Tiffany with Tiffany's Tutoring and Consulting LLC, guiding you through these SAT education streets. So we're again in the SAT free test, FREE free test on College Board test number 4. We're going to get into some more complex quadratics, and they're really not more complex. I would just say it just takes a little more work to solve them. So that's where the complexity comes in. Number 12, what is the positive solution to the given equation? Now, you can go onto the online graphing Desmos calculator, which is embedded into the SAT test. Graph this function and you can see the solutions. The solutions are the x intercepts. But if you want to solve it algebraically, this is what I would suggest you do. So, first, you're going to start out rewriting the equation on your paper. Now, I personally like to make a positive. So I'm going to add 4x squared to both sides. And I'm also at the same time going to add 7x. Again, you don't have to do this at the same time. I just like to do it all together. Again, using inverse operations. And then I'm going to flip it around so that you can see that this is what I have. So now what I'm going to do is, and this will give you a little review on quadratics, I'm going to identify A, B, and C. Now, if I identify A, B, and C, I can use the quadratic formula to put it in the quadratic formula to get your solutions. But I'm going to do the area model. I really like the area model just because it can be done when your answer needs to be in a factorable form. Okay. So I'm gonna go ahead and do the area model. Go ahead and draw my box. So in the area model, I draw a 2 by 2 box. I always put my A term in the top left, and then my C term goes in the bottom right. Then I'm gonna multiply A and C, and that gives me negative 144. So I'm going to look for the factors of negative 144. Okay, I want the factors of 144, negative 144 that multiply to get you 144, but then also add to get you 7. Now, I'm not going to go through the laundry list, but basically you can go through and do this on your calculator. I'm going to get right down to the meat and potatoes of things and start right here at the 9 and 16. So that looks like that's going to get me closest to 7, but there's an issue. My answer is negative 144. So that means that in order to get a negative number, when I have two numbers, one number must be positive, one must be negative. So I'm going to look at that sign of B. Okay, if B is positive, that means my bigger factor had to have been positive. So I'm going to make my small factors negative. Okay, and when I add negative 9 and positive 16, I get positive 7. So that's how I'm going to check. Now, if you make the mistake of making the other factor negative, you'll see that that would not be, that will give you a negative 7, and you would know to just flip over your sign. I'm going to take those factors and put them back into my box. Now, it doesn't matter where these factors are. I'm just going to choose negative 9 here, positive 16 here. In the area model, again, these two don't matter. Now I'm going to find the greatest common factor between for the top and the left. Okay. So the greatest common factor between 4x squared and 6x is 4x. How did I get that? I'm glad you asked. The largest thing I can pull out of both of those is a 4, which 16 divided by 4 is 4. 4 divided by 4 is 1. And each of those at least has one x. I can't pull out an x squared because 16x is just one x. My next one. Next, I'm going to do minus 9. That's the biggest thing that I can pull out of both of those. And again, it's based on both of those. So also with the negative 9, because it's leading with negative, that's how I'm pulling out a negative 9. Going over to my left side again, I'm only doing the top and the left. The biggest thing I can pull out is an X. 9 and 4 are not factors of each other. So therefore, I cannot pull out, and they don't have any common factors. So the biggest thing I can pull out is an X. And then 16x minus 36, I can pull out a 4. That's the largest thing I can pull out of both of those where they're common factors. Now, the last step is I'm going to set both of these equal to 0. Okay. And then that's how I'm going to solve. And this is based on the zero product property. I solved the first one, x is negative 4. Well, we're looking for the positive solution. So then I'm going to solve the second one, again, doing inverse operations. And when I do that, again, division, subtraction, and addition are inverses. Division and multiplication are inverses. I get 9 over 4, which is answer B. Letter B is my answer. Now, again, there's several ways you could do it. You could also use the quadratic formula and plug that into your calculator, and that's really good to plug into the Desmos calculator. Since we're talking about the quadratic formula, I'm gonna go ahead and write it down here. X equals the opposite of B plus or minus the square root of b squared minus 4ac all over 2a. So this is the quadratic formula. We're going to come back to this. So that's why I put it down here. Again, you can plug that in and get your answers once it is in standard form. But remember, it has to be in this standard form so that you can get A, B, and C. All right, the next one. It gives you f of x equals x minus 10 parentheses x plus 13. Again, you can put this into Desmos and find your vertex there because that's where your minimum or your maximum is your vertex. But let's do it algebraically. So if I do this algebraically, what I want to do is I want to get this in standard form so that I can get my A, B, and C. And the way that I do that is I'm going to multiply those two. Now I can multiply those two a lot of different ways. I'm going to show you how to multiply using that same area model, but this time we're starting on the outside and then we're going to come to the inside. Okay, so this is kind of like Punnett squares. You're going to find the area of these two of this box. So that's x times x is x squared. 13 times x is 13x. Negative 10 times x is negative 10x. Negative 10 times 13 is negative 130. Then I'm going to combine like terms. I see here that's going to give me this final answer. Okay, so you can do that using distributive property, yes, but I like the area model because again, it can be used for multiplying or factoring, and that way you can kind of have two in one. All right, so now that we have this in standard form, we're going to identify A, B, and C. Okay, now here's where I wrote that handy dandy quadratic formula. This quadratic formula has multiple equations. The first, or multiple things you can get out of it. The first thing is the entire thing will give you the solutions or the roots or the x-intercepts of the quadratic. The second thing it can give you is the discriminant, which is everything that's under the square root. That's going to tell you how many real solutions you have. And then last but not least, you can get the x portion of the vertex, which is minus b over 2a. This is going to give you the x portion of your vertex. So if I just do a little plug and chug, I can see that the x portion of my vertex is negative 3 over 2. Again, I got that from the quadratic formula. All right, hope this helps. It takes a little bit of time, but again, it's just a kind of detailed. If you're running long time, definitely put it in Desmos, and you can also use that Desmos to check your answer. All right, talk to y'all later. Peace.